See this problem. Two 120 volt light bulbs, one of 25 watt and another of 200 watt, are connected in series. One bulb burnt out almost instantaneously. Which one was burnt and why? So our motto is, there are two bulbs which are connected at parallel combination like this. And one is having V1 P1 power rating and another is having V2 P2 power rating. They are connected at a potential V. Here V1, V2 and V are same. And the moment when you switched on this circuit, one of the bulb is going to be blown out. What is the bulb that they have blown out? That we need to find out. If we assume it as R1 and R2, we need to find out which one has burnt out, R1 or R2. That is our motto. Now I'm going to investigate the quantities that I have given. The power ratings are V1 P1 for R1 is equal to 120 volts and 25 watts. V2 P2 is equal to 120 volts and 200 watts. And the potential that you are connecting to these bulbs are 120 volts. So that's the information from the problem. And now I am going to resolve the problem. So first of all, to know the bulb which is burnt out, we need to find out the current that it can sustain. So for I1, that means the current that can be sustainable by the first resistor is I1 is equal to, I am writing P1 by V1, because power P is equal to VI. So for I, with the given quantities power and voltage, I am finding the current. That is equal to, for first bulb it is 25 watts by 120, that is equal to, I'll get nearly 0.2 amperes. And for current 2, it is P2 by V2, that is equal to 200 by 120, that is nearly 1.66 amperes. That means here the current that can be sustainable by the bulb 1 is less than bulb 2. So with 0.2 amperes only, that means the first bulb that can sustain with the current 0.2 only. If that is connected in a circuit which is drawing more current than that, then the bulb will burn out. And next one, I want to find the resistances of these two bulbs. R1 is equal to V square by P1. We know that P is equal to V square by R. So I am finding the resistance with the given power rating, that is equal to V1 square by P1 square, that is 120 whole square divided by 25. And R2 is equal to V2 square by P2, that is equal to 120 square by 200. Clearly from these two, which is having more denominator, that value is less. So R1 is greater than R2. Here the resistor which is having more resistance is drawing less current. The resistance with less resistance, the resistor with less resistance drawing more current. So the moment when you connected these resistors in a circuit, the lesser resistors like R2 will try to draw more current, that is 1.66 amperes. So at that moment there may be a chance, or there is a chance to come to get the currents, to get more current through R1. So R1 may be the bulb which can blown out the moment when you switch it on the circuit, because the current that can sustainable by R1 is very less. So when the moment you switch it on, so the current which passing through the circuit may go to the higher levels, like abrupt change in the current, so at that moment it may blown out. So 25-watt bulb may blown out.